In this video walkthrough lesson, we're going to take a look at our fractions module, and this is lesson 5-1.1, Understanding and Creating Equivalent Fractions. We'll be looking at a variety of fractions, all equivalent to 1/2. We'll be using fraction strips, number line, the array method, area model, and we'll be handling equivalent fractions mathematically as well. These are the standards featured in this video walkthrough lesson, and we'll be using this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our fractions video walkthroughs. It's entitled Fractions Module, Lesson 5-1.1, Understanding and Creating Equivalent Fractions. And you'll notice that it comes with blank fraction strips as well as divided fraction strips. Feel free to use these to create other lessons if you'd like. However, we have some directions for this lesson. Fold a blank fraction strip in half, unfold it and label each section. Then lay the fraction strip below the number line and mark off 0 and 1 above the line, and 0 halves, 1/2, and 2 halves below the line. Then make equivalent fractions 1/2, 2/4, 3/6, 4/8 in the chart below. And again, we'll be using the array method, the area model, and we'll handle those mathematically as well. Let's take a look at the first step. In the first step, you need to cut out a blank fraction strip. Go ahead and do that now, and you could pause the video if you'd like and resume when you're ready. And once you've cut out the blank fraction strip, you could fold it in half right down the center and label each side 1/2, or 1 out of 2 units. In this case, or 1 out of 2 parts that make up the whole fraction strip. Now, when you're using a fraction strip like this and you place it above a number line, you're really showing fractional distances. Now, in this case, our directions say to label one end as 0 up above, and then the other end, reading it left to right, as 1 or 1 whole. You might think of or imagine running a race, and you're running, say it's just a kilometer sprint type race, and you're running along and you get to the halfway point, and this would be the 1/2 kilometer mark, and you continue another 1/2 kilometer to the finish where you've run 1 whole kilometer. The other part of the directions are to label below the line as 0 halves, lining right up with 0 here, so we have 0 halves, and right halfway between would be 1/2, right through here would be 1/2, and when you've finished up, you're all the way done, you've run that distance, it would be 2 halves or 1 whole race or 1 whole kilometer. You could even, a linear measure is really handy when you're measuring something, when you're building something out of wood. You need to measure maybe 1/2 of something, 1/2 inch, 1/2 a centimeter, and such. So now we can transfer this thinking about fractions on a number line or linear distance into areas or pictorial methods. So when we're dealing with a denominator of 2, you want to make 2 equal parts. So we're going to go ahead and do that. We will divide these, and if you look on your worksheet, you'll see squares, 4 of them. To go ahead and divide them vertically, right down the middle. So we're making 2 parts for each of these. Continue this down below. And now go ahead and shade in 1/2 or 1/2 of each of these. let's see, 1 out of 2 parts that make up that whole. It could be a pizza, could be anything really that you can imagine that you want to divide into 2 equally. Be a sandwich or whatever you'd like. So I'm in the mood for food right now. Anyhow, fractions really can be applied to anything imaginable. So as you can see, all of these area models, in this case it's the square, they're all divided into 2 equal parts, with one part being shaded. So I'm going to go ahead and label this first one as being 1/2. And now we want to make equivalent fractions. Well, we could do this. Say you wanted to have the same pizza and you wanted to divide it in half again, but this time we're going to partition it or cut across horizontally, making 4 equal parts. Well, what do? Well, we can handle this mathematically. We'll go ahead and do that. So now we had 1/2 that we started with, and we'll set it equal to another fraction. And originally we had 2 equal parts. That's where we got our denominator of 2 that made up that 1 whole. Or you could say it was 1 whole divided into 2 equal parts, because really every fraction is also a division problem. So it would be 1 divided by 2. See that? 1 whole pizza divided by 2. And you've got 2 equal parts. Each part being, I bet you guessed it, 1/2. Good for you. Now, in this case, we've got 4 equal parts. So our new denominator would be 4. So we'll make 4 equal parts to make up this 1 whole. So now we can handle this mathematically, as I was saying. We can think to ourselves, 2 times what? 2 times what would equal 4? And you're probably thinking, oh, I know that one. 2 times 2 equals 4. Well, you're exactly right. So what you do to the denominator, you must do to the numerator. And we'll multiply 1 times 2, and that would be 2. And if you look at this, I mean, take a look at that. We've got 2 over 2 right there. You might be thinking, 2 over 2. Well, if the numerator and denominator are the same, that equals 1 whole. You'd be right. So in essence, you're multiplying 1/2 times 1, which is the identity property, and that's true. And if you think about it, 1/2 represents the same part of the whole as 2/4. 2/4 represents the same part of the whole as 1/2. So there you have it. So this section that's shaded would represent 2/4. Pretty cool. So we started with 1/2, and then we subdivided again, okay? And we saw that if we multiply by 2 over 2, we would get an equivalent fraction. Well, let's try something different. Say we wanted to have, in this case, 2 more partitions horizontally. So in this case, we've got 6 equal parts. So we could take that same original fraction of 1/2, again, the same original fraction, 1/2. In this case, we're going to multiply it by something, and now we're going to have 6 equal parts that make up that whole. So our denominator would be 6. So 6 equal parts would make up this whole. So again, the same line of thinking. We could think to ourselves, 2 times what equals 6? And you're probably thinking 3. And if you were, good for you. That's true. 2 times 3 equals 6. So let's apply that to the numerator. 1 times 3 would equal 3. And if this works out, and I think it does, it sure does, 3 out of 6, or 3/6, would represent the same part of the whole. as 1/2 did, as 2/4 did. So yes, indeed, we have another equivalent fraction. So let's get that down there. That would be 3 out of 6, or 3/6, equals 1/2, equals 2/4. Let's try this one more time. We have another model left to divide. So what would happen if we wanted to divide this up into 8 equal parts? What would happen then? Well, let's set it up as we did before. We started off with the same fraction in lowest terms. It would be 1/2. So we started off with that 1/2. And now we want it to equal a fraction with the denominator of, you're probably thinking, oh, there's 8 equal parts there, so 8 equal parts make up that whole. You'd be correct. So we want to make it as a fraction with a denominator of 8, or eighths is our unit, our fractional unit in this case. So now we're thinking to ourselves, 2 times what equals 8? And again, you're probably thinking, I know that. 2 times 4 equals 8, and you'd be right again, so good for you. What you do to the denominator, you must do to the numerator. Again, that's the identity property working on there. You don't want to change the value of the fraction. So if you multiply both numerator and the denominator by the same number, you're going to end up with an equivalent fraction each time you do this. So now let's check it out. 1 times 4 equals 4. And look at that. We've got 4/8, and sure enough, 4 out of 8 of these sections, equal parts, they're shaded in, so it's 4 out of 8, or 4/8. Aha. So 4/8 represents the same part of the whole as 3/6. Same as 2/4, same as 1/2. They are all equivalent fractions which represent the same part of the whole. So now, I mean, you could continue this really forever, and now that you've got the visually got the hang of this, I mean, you could start off with 1/2 and multiply it really by anything. Let's try something a little random here. You can really multiply it by anything, and we'll just pick out a number here. Let's check it out. Okay. So we'll multiply both the numerator and the denominator by this 5. Let's check it out, see what happens. So we're going to multiply the numerator and the denominator by 5, or 5/5. See what happens. 1 times 5 would equal 5, and 2 times 5 would equal 10. And that would be an equivalent fraction. I mean, you could continue this pattern forever, and if you did that, I mean, you're multiplying by the same number with the numerator and denominator, you were going to end up with an equivalent fraction. Huh. So anytime, a basic check would be, if you multiply the numerator, or double the numerator, if you multiply it by 2, you're going to get the denominator. Let's check it out. 1 times 2 would be 2. Yep, that checks out. 2 doubled, or 2 times 2 would be 4. Yep. 3 times 2 is 6. 4 times 2 is 8. And that checks out with the one we just made randomly. 5 times 2 would equal 10. So that indeed represents the same part of the whole. Half of the whole. Definitely. Anytime the numerator is half the denominator, you've got an equivalent fraction to 1/2. Now, let's take a look at the array method. The array method, you've got a 1x2 array, and with one part of the set you're focusing on, There you go. We've got 1 out of 2, and that is equivalent to 1/2. Now let's look at 2/4. So it's a 2 by 2 array. It's 4 equal parts. That are 4 parts make up the set. That's our denominator. 4 parts make up the set. 2 parts made up the set, according to our denominator up here. And now, if it's equivalent to 1/2, then 1 out of every 2, we would really have to circle here. Let's check it out. Or you'd be focusing on it, or shading in, or for example. It's easier to show circled parts of a set. So 1 out of this group of 2, and then 1 out of this group of 2, and you can see that 2 out of the 4 would be 2/4. Now, with this array, you've got a 2 by 3 or a 3 by 2 array you could set up. As long as you have 6 parts in your array, according to your denominator here. And again, we've got 3 out of the 6, or you could think of it in terms of 1/2, 1 out of every 2. So 1 out of these 2, 1 out of these 2, and 1 out of this group of 2. Look at that. So you've got 3/6, or 3 out of 6, and that would be 3/6. And then the final array, we have 8 parts that make up your array. You're talking about fractions of a set. Sometimes it's easy to think about, maybe you have a collection of things. You might have collectible toy cars or something like that, and let's say half of them would be red. So you represent that by 1 out of every 2, 1 out of this group of 2, 1 out of this group of 2, 1 out of this group of 2, or simply think of it as 4 out of the total of 8 would be represented there. So now we've got 4/8 as an array shown on an area, or handled mathematically. Look at that. So the check, again, for determining whether an array, a fraction of an array, is equivalent to 1/2 is really, you think of it in groups of 2, and 1 out of every 2 would be focused upon, or shaded in, or shown in some way. So there was a quick look at our fractions module, lesson 5-1.1, and it was understanding and creating equivalent fractions. We could even take it one step further. You could feel free to stop the video now, or if you wanted to take a look at cutting out more fraction strips to shade in or represent the whole, we could do that. Now, the second we had 2/4, so I'm going to go ahead and bring over 2/4. You can see that will line that right up there. 2/4. You can see 1, 2, 3, 4 equal parts, and 2/4 would be right here lined up, equivalent with 1/2. Next up, we did 3/6, so you can find 3/6. You can cut it out if you'd like, and line it up here. And you could see that 3/6 are halfway across. 1, 2, 3 out of 6 would line right up with 1/2. It's equivalent to 1/2. In terms of distance, it would be the same distance or same part of the whole. Like our example given earlier was 1 kilometer or 1 whole race. 3/6 would be halfway across. And finally, we did 4/8. So we had 4/8. Again, 1, 2, 3, 4 out of 8. Halfway across, 4/8 of the way across would line up exactly with 1/2, and it would be the same distance covered. And even with our random example that we made with the dice, we have to find our tenth. So we're looking for the denominator 10, or 10 equal parts in our fraction strips. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the one we need. We drag that over and laid it on top of there. You can see that 5/10 would line up right with 1/2. It's the same distance across, same part of the whole fraction strip. And there you'd have it. They would be equivalent. So thanks for checking out worksheetsandwalkthroughs.com. And we'll see you again next time.